Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Tom Singer and Craig Brown.
This is the Digital Enterprise Society podcast. Thank you so much for selecting our little show. We know that you have a lot of podcasts that you can choose from, but this is the one that is a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Tom Singer, and I have the honor to co-host this show with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, it's Wednesday. Here we are again.
Hey, Tom, it's good to hear your voice. And you know what? It's happening. We're getting back together. I am now at my fourth physical event, but the first one outside of Detroit. And I'm really looking forward to it. Later this week, I get to debate with Mark at this conference about supply chain issues and how virtual and PLM could help all that. That's later in the week. I hope we record it so we can play it here on the podcast. And today we've got a guest coming back with us that we interviewed 3 years ago. And I am hoping that we have more of these so we can just say the darn pandemic is over, right? It's just nice to see we came out the other side, right?
Well, I do like the fact that we're starting to bring back some guests because you know what? The world has changed a lot in 3 years. In the summer of 2019, Dr. Michael Greaves was with us. And now, as we are in the spring of 2022, he is back. And today we're going to talk about digital twins. And Dr. Greaves is the executive director and chief scientist at the Digital Twin Institute. And his life's work is working on this movement of moving from physical to the digital world. He designs, tests, manufactures, and supports everything throughout the manufacturing process digitally so that it helps manufacturers save themselves from stupid mistakes of doing it in the physical world. He's also a very successful author, and several of his books are widely used by everyone who works in and around PLM. So, Mike Greaves, welcome back to the Digital Enterprise Society podcast.
Thanks. It's a pleasure to be back, and it seems like it was a long 3 years, but thanks for inviting me back.
No, we're glad to have you back. And to get everybody started, not everybody may remember the show from 3 years ago. Give us a little bit of your background. How did you get into this world of PLM and digital twins?
Yeah, so I mean, I've been involved with computers since I was a teenager, and that goes way, way back. In fact, in the 60s, I was a systems programmer on mainframe systems. And by the way, they were really powerful machines. I had 140,000 bytes to work with. So your watch has a hell of a lot more capability. But I started off as a systems programmer on time-sharing operating systems. Got to work with some things like the ELIAC 4, which was the first supercomputer that reported into me. By the way, that was had about a speed of 25 megaflops. Today, the Xbox has 15 teraflops. So, and by the way, it took up a huge amount of space versus the little console you have. So we moved a far amount. I was involved obviously in computers very early on, but started my own company and was in the forefront of the local area network and that thing, and took it public in the mid 90s, and then decided that I'd had enough dealing with corporate America, even when it was my corporate America, and went back and got my doctorate degree from Case Western, and then stumbled into the product lifecycle management area. In fact, courtesy of Craig's old company, General Motors and EDS, and I had been talking about the fact that if we used information, we could have everybody fit, as opposed to, if you remember, the days of Covisint, where in essence the big guys, no offense, Craig, were out to make life difficult for their suppliers. And so that became product lifecycle management, and I wrote the first book on that. And the underlying premise all along with that was the idea that we could move work into the virtual world and use the advantage of the fact that we were going to have the digital world explode at exponential rate in terms of computing, storage, and communications capability, while in fact inflation is now really biting us, and that the physical world goes up in cost. And so the idea there was as you said, we want to make all our mistakes in the virtual world, and only when we get it all right do we go out to expensive atoms around. I was particularly to NASA where I was a consultant at the time, because oops is not a word you want to use when you're launching a rocket. And so the ability of being able to do those sorts of things using the digital twin to be able to design, test, manufacture, and support the product ahead of time was critical. Then when you actually have a product, to be able to then have its own digital twin, which is a specific instance of that particular digital twin, to track it throughout its entire life is extremely important. And if I can aggregate all those different things that I'm making, I can then do things like predict their performance and fix problems before they occur. But one of the sort of the opportunities is if you remember the Malaysian Airlines, we'll never have another Malaysian Airlines incident, because its digital twin will know exactly where it is in the world at all particular points in time. So the ability of having a digital twin is certainly important in terms of staying connected to its physical counterpart. But the work that we can do at the beginning in terms of moving work into the virtual world and trading off very expensive physical resources for information, that resources that we would wind up wasting, is I think why the digital twin has exploded so dramatically over the last few years.
Well, Mike, it's great to hear you again, and it's great to see you. I hope to look forward to the day we can see each other in person. It won't be too long now. You know, this world of, or the terminology of digital twin has gotten really messy. And it was messy when we talked 3 years ago, and now it's really messy. There's just, you used the example earlier about if you search on the term digital twin with your favorite search engine, now you get tens of millions of hits instead of just a few million hits. In your discussion, the view you just gave about aggregate and instances and making wise decisions with virtual models instead of physical mistakes, you've done some definitions about digital twin, and let's clean this up. Let's help the audience understand. So tell us the kinds of digital twins you have, and then where that can lead us.
Yeah, so in terms of a definition of digital twins, I think the last time I looked, there were 400,000 definitions also. So I'm always sort of suspicious of word definitions, because I liken them to the blind man and the elephant. Is depending on which part of the elephant you're touching is going to determine as to how you define it. So if you remember the blind man and the elephant parable, you know, one touches the tusk and thinks it's a spear, the other touches the tail and thinks it's a rope. So that's why we need to drive from use cases. But if we're talking about the whole elephant here, the whole digital twin, I divide it into three types. The digital twin prototype, or the prototypical digital twin, actually exists before there's anything physical, because this is the work we want to do in basically designing the product, testing the product, manufacturing the product, and supporting the product. And if we can do that in the virtual world with virtual reality, we can do a far better job of designing a product that's really going to perform for the user the way they expect, which, by the way, is my definition of quality product. Those are all the products that we can make. And so those are all the products and the variants. When we start making things, and I'm talking about complicated things, so a paperclip doesn't need a digital twin. An automobile, a high-end automobile, or an airplane or a ship do need digital twins. And in that particular case, we now don't have that it has a GD&T of plus or minus 0.05. It actually has a number that we've manufactured. And so it also has a serial number of specific parts. So we actually have the item that we want to keep track of throughout its entire life and collect information on how it behaves. But then, so that's a digital twin instance. When I want to get some real value out of that, because I can interrogate those digital twin instances without having to be in physical proximity for that product. But when I take all those digital twin instances, I can now do some really interesting stuff and do some predictions of how that thing's going to perform. And so what I want to do is be able to Industry 4.0, which is getting a lot of attention. One of its premises was, before they sort of adopted some of my digital twin stuff, is that you want to decrease the time between having a problem and being able to remediate it. My perspective is, I don't ever want to have the problem. I want to predict that the problem is going to occur and get out in front and fix it before it ever happens. So if I have a glitch of a robot on an assembly line, I want to be able to look out into the future and see, oh, I'm going to get a bottleneck there. So I'm going to go fix that before the bottleneck actually occurs, not to reduce the amount of time that I have the bottleneck. So the three kinds of digital twins, the types of digital twins, are the prototypical digital twin, the digital twin instance, and the digital twin aggregate, which is all the population of things where I can collect big data on them.
Okay, so this helps. This helps clarify the terminology. And when you and I first met, I had the methods guys at Powertrain. I think we met in Pontiac, and we were talking about exactly how do you get the community to accept the virtual prototype. So only the first step that you mentioned, when they're used to building this build and breaks thing, right? Put it in a lab or put it on the road and break it and then fix it, right? And get very good at the fixing cycle, like you mentioned there at the end. The notion of having a bunch of instance models or even an aggregate of all of them together, that was still over the horizon. Now, it's interesting today in real world, problems with batteries in electric vehicles, it's aggregate digital twins that's actually helping them diagnose the problem much quicker, which is great, but they're still relying on physical tests, by the way, too. So what are some of the impediments to people being effective with digital twins? Is it just knowledge? Is it just learning, or is there other impediments?
I think there are other impediments. So one big one is overhyping it. So you go into your boss and say, give me $500 million and I'm going to give you a digital twin of the world. And Craig, having been at GM, you'll know that you probably can count in milliseconds the amount of time it takes you to get thrown out of that office.
Yeah. You can tell them if you're going to make more profit, but you can't tell them you're going to have a model of the world.
Yeah. So there's a lot of overhype and overpromising. So it needs to be driven by use cases. The cultural thing is going to be a big one. I mean, what we're sort of seeing is the digital natives who are coming along are very, very comfortable in that. The senior managements have issues, and there's a thing that I don't know if I've mentioned before, but it's retirementitis, and that's senior managers who are looking at retirement and saying, "Oh my God, do I really want to do a project like this that may not work?"
No.
And so, please get me to retirement without me having to deal with this, please.
Well, but Mike, you and I are that age. I've joined you in semi-retirement now, right? And I was an adopter. I mean, I think you're right. There are a lot of people, maybe not just old people, just people that for whatever reasons have forgotten to learn and they don't want to learn. And so they have this old practice of test 100 samples. And if only one breaks, go ahead and ship it to production. It's a very old mindset. And you're right. Those guys need to move on. If it's retirement, great. If it's other things, so be it. But, yeah, impediments, unwillingness to change. I tell you what, in this world, you better be willing to change. Otherwise, you won't survive. Other impediments?
Yeah, I mean, by the way, Craig, I think that you were unusual, especially for General Motors. Some of the big companies, retirementitis is a big thing. And so I think if you think back, there were a lot of people that really didn't want to adopt. And you're right, it's not solely an age thing. But there is sort of a correlation between age and ability to change. And you and I happen to be some of the unusual ones for that. The other thing is not having use cases. So being able to do one of these boil the ocean sort of projects without understanding where you're getting value. So an inability to articulate the value you're going to get. And that means that it's going to be a problem to do the thing that you said is I'm going to make more profit. So if you don't have the levers to explain to people that are technically don't have the chops to do this, you need to have a real good cut case of of here's the sorts of things that I'm going to save in terms of cost, and this is how we're going to make more profit if you basically invest in that project. Yeah. So that's, and in the technical people get so enamored with the technology, they forget about the fact that they got to get the money to be able to do it, and they've got to show value.
Yeah, and a lot of us have used computers to eke out efficiency over the past couple decades, right? And there were lots of opportunities because there was lots of waste and manual systems. But it's interesting. Talk about profit and talk about costs for a second. You know, the thing that's really upon us with adding more features to a product that are largely software based. They still take time to develop reliably, by the way, but they don't take material expenses like a factory, right? It's a different kind of material expense. It's the talented people. And so they can bring more revenue for the same base. And so this notion that investing in digital everything would bring me more revenue, not necessarily reduce my physical costs. That's another side of this profit side that we're not very good at talking about, right? And yet you can look at other industries, be it the phone industry or whatever gadget you're willing to pay money for to bring stuff to your fingertips. Well, they're collecting a little fee, right? And the phone is still the same. And so my point is, it's not just efficiency. The trouble with us big manufacturing companies, where we came from, well, it was about efficiency because there was a lot of waste, right? So there is cost reduction. That's good. But there's also revenue increase, which could, if you manage your company well, should lead to profit increase, right? So
yeah, and having been a board member on public companies, you are absolutely right. But it's a tougher sell because you can control costs. You can only predict revenue.
That's a good.
So you got to be a little bit careful about promising revenue. The only time I've ever seen it really take off is during the .com era, where you could convince people, give me $1 trillion to ship dog food to people. But while I don't disagree with you, is you have to, I think, show some ability to decrease your costs or have a really good story about increasing revenue.
Okay. So you introduced another qualifier in talking about digital twins, and that was the intelligent digital twin. And you've written a few papers. I guess they're in draft state or preliminary state. But why? What's behind the notion of an intelligent digital twin?
So I think from my perspective, it is how do we basically apply this things coming down the line of computers being intelligent. And I put, quote marks around that because I really don't think that they're truly intelligent. They're assistants. So the whole idea between artificial intelligence is that it's not going to replace humans. It's going to help humans. So we got plenty of humans. We don't need them replaced, but they do need help. Okay. I mean, let me take an example that humans have a terrible time with two things. One is confirmation bias, and the second is optimism. I mean, people sort of try to fit the data into their frame reference, and they get themselves in trouble because they don't look at other alternatives. And then in optimism, I mean, there's study after study that says, that people doing projects, even though they've gone way over, predict that they're going to come in under budget, under time. So I view AI as intelligent digital twin as helping that. So there's sort of four kind of characteristics. One is the current digital twin is passive, which means that it collects the data and then humans do the work in terms of applying that. And where I think the intelligent digital twin is going to be active. So digital twin is going to be hooked and working everything. So my front-running simulation, the ability of having a crystal ball in your product to predict the next few minutes, hours, days, whatever you can do is going to be an opportunity. So that means that we're going to have better communication. So we're going to go from offline to online. Currently, we are doing the goal giving in terms of, here's what we want to accomplish. And remember, most of human existence is about doing a task, accomplishing a task with the minimum amount of resources. I think AI is going to help us to do goal seeking while minimizing resources. So it's going to look at the areas that we just don't have the bandwidth to go find, and it's going to look at the whole design or behavior space as opposed to the ones that we sort of, as humans, have the ability to do. And then finally, it will be predictive. So it's going to have this front-running simulation predicting the future all the time, as opposed to us asking, "Hey, what's going to happen?" So it is basically applying AI and machine learning to the digital twin to have it be an active participant, helping humans do a better job.
No, I like the way you talk about AI assisting humans or helping humans. There's a lot too much clamor about, oh my goodness, it's the robot overlords and they're going to replace us with AI. That's not what AI can do. So I like your connotation that it's an aid so that we keep making better decisions, and that's really true. Now, you've mentioned use cases a couple of times, and let's dig into that for just a second. One of the things that I think helps you build a better product, and when we were all in school, there were things about safety margins. And so the way my professor taught me, it was, well, if you're not sure that thing's going to perform, it could be a wing, it could be a propeller, it could be, well, the digital computers were just starting to come out. If you're not sure, then apply a safety margin. A safety margin could be redundancy in computers. It could be, plan for double the load, and instead of the typical load, plan for double the load, and then you'll be robust to breakage. So this notion of robustness and now intelligent digital twins is going to need a use case that says, well, what about the really abnormal chuck hole that we all have in Michigan? But what about the extraordinary use case that can break a system? And in mechanical engineering, especially the car business, we got pretty good at getting our arms around all that. But as new technology, be it additive or new materials or all these new batteries, as we're now discovering their weaknesses, it seems to me exploring robustness ought to be something these intelligent digital twins could help with. Do you agree? What do you think? I mean, I think the use cases then have to expand. At least that's my way of organizing it. What do you think?
So I think you're absolutely right about that, and it goes back to my point that the AI will explore all the other areas that we haven't. Think about it. In nature, how does this work? Well, nature does all possible combinations and lets the reality sort them all out, and so that's how you get evolution. AI, and so humans can't afford to do that. We can't afford to explore all possible possibilities and then let nature sort them out. In fact, it's probably a big recipe for lawsuits if you think about that.
Yeah, or a pandemic failure, but let's not go there.
Yeah, I agree. But if I move this stuff into the virtual world, AI is almost costless. So it can explore all the possible combinations. So think about crash testing, which was in your area, is the fact that you can only afford to do certain orientations of cross tests. In the virtual world, AI could do crash tests at every, small increment, all 360 of them, if not smaller, and determine if there's an area, a crumple zone that would occur in a crash way that isn't going to show up on a physical test, which, by the way, goes back to your point about physical testing. I think virtual testing is going to eclipse that. And by the way, that is a cultural problem. So I think that if you could do a better job in terms of being able to understand all the possibilities, then you're not going to, your safety factors are going to shrink pretty dramatically, which, by the way, will lead to decrease in cost, right?
That's right.
So it, as you have computing, going up at an exponential rate and costs, going up at the cost of inflation, you're going to have this ability of being able to do a better job in terms of performance design, because you're now going to have to not say, gee, I'm going to make it 2 times stronger because I don't know where that is. I mean, you run enough of these models and simulations, and you've got your physics right, you'll know where you're at without having to build in pretty big safety factors, and that will decrease costs.
You know, the mention about Industry 4.0, and it's largely about feedback from the manufacturing floor and improving the flow of material on the floor, including finding problems. It seems to me we want, and we sort of have it in places if we just think about it. Seems to me you want the same thing with the end user of the product, and let's just assume that the end user wants that kind of oversight. But my point is that's how you discover the missing use cases. The battery failures that are occurring in electric vehicles are largely either a manufacturing aha, they didn't figure it out before we started mass production, or in fact, people are charging and discharging in climates unexpected, cold or hot, and they're brutalizing batteries in a way they didn't expect, right? And so my point is continuously monitoring your notion of this instance digital twin, collecting data from real usage would lead to better use cases, which then the AI could work on and develop the next round of testing, even if you apply changes out in the field. And I just think this is one of the promises of computers. Before you and I leave this earth, we will in fact see people making more and more robust products because they're applying computers. I love the way you summarized in your lecture recently how the bits are getting cheaper, right? The atoms are the same price or going up if there's inflation, and the computer simulations are getting cheaper. In our lifetime, it's just amazing. I was a few years behind you, but I still spent a lot of energy cramming my programs into a big mainframe and then into a flight computer that barely had any memory. And now we don't even talk about that anymore. We got oodles of throughput and oodles of memory everywhere. So I don't know. I think where you're going with digital twins, intelligent digital twins, is right. And I also think expanding use cases based on field use or customers using products, people got to think that through, and it needs to be there. It needs to be an integral part of their business. That will change processes. And the people that don't want to embrace change, well, have a good retirement.
I absolutely agree. And then we haven't even talked about this, and maybe it's time for another podcast in a few years. But when we get to autonomous things with their own AI in it, we're really going to need digital twins.
Yep. So this has been interesting, Mike. I appreciate you catching up with us. And in a few more years, hopefully we don't survive another pandemic. We don't deal with one. And we're just talking about, isn't it cool how autonomous vehicles are working, whether they're ground-based or airborne? I've been talking to both communities. Those technologies are coming. They're kind of interesting. So, Tom, back to you.
No, this has been a great discussion. Mike, thanks for joining us again. We don't want to wait 3 years till we have you back. Maybe we'll have you back a little sooner than that for the next interview. But
face-to-face, Tom.
Yeah, we should do it face-to-face.
Tell me which event, and we'll get everybody there, okay?
Nice. Well, you know what? We are starting, as we've said, Craig, we've been excited as we've seen this little crack open in society, and we're getting back to face-to-face meetings. There's also talk that the Digital Enterprise Society will be hosting its in-person event in July. So pay attention for all of you who are part of the Digital Enterprise Society. Watch your emails, go to the website and check up. Information should be coming soon about the possibility of an in-person event. So that'll be exciting.
Yeah, and Mike, if you're back up our way in Michigan for the summer, I know sometimes you are, well then join us. It'll be in the Detroit suburbs somewhere. I don't know the details yet.
Details are coming soon, Greg.
I still have my house in Commerce, so let me know.
Nice.
Okay.
Nice.
It'd probably be a short drive, I would guess. It won't be too far.
Information on all that, everybody, is coming very soon. But in the meantime, we want you to join us here on this podcast every single week for more thoughts, ideas, and actionable information around your career in product lifecycle management. The Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Visit the website at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.